Universal laws. Um, Actually, the more you get into universal laws, the simpler things get. Um, and the more pushback I get, the more magnetism I get, the more electric charge I get from the rest of the scientific community. All right. Um, Mass is charge. It's not about protons and electrons. It's not about positive particles running around, chasing around negative particles. Mass is charge. A moving mass generates a magnetic field. Okay? A rotating mass is a moving mass. It's It's twisting the magnetic field, and it generates a magnetic field in a twist. So, the faster a mass moves through space, the harder it is to move faster because it generates a bow shock. And this is the part that confused Einstein, and Einstein couldn't stand it. It was the buildup of mass. So as a particle moves faster, accelerates, more specifically, as a particle accelerates through space, it has to put more and more energy into doing any movement that it's doing. Meaning, it's building mass as it moves forward. But you don't see the mass, right, until it hits something. And then all of a sudden, all that mass is seen, right? Consider it a bow shock. A magnetic field is generated in front of it. Now, when you rotate, you're literally grabbing the magnetic field and you're spinning it and you're twisting it. Remember I said the twist and the twist and the counter twist. So the mass is twisting the magnetic field. So the magnetic field is twisting back. And we get magnetic fields. That's why Maxwell went on and said there is no monopole. I've been saying that from the start. There is no monopole. There's no such thing as a particle that just transmits positive energy and another particle that transmits negative energy, and then somehow they make a magnet. No. It's one particle or one object, whatever, one mass, creating a magnetic field. On the atomic scale, we can't see it. On the galactic scale, we absolutely can. On these solar systems, we can absolutely see it. We can't see it on the atomic, so it confuses people, and they screwed it all up. They screwed it up big time. And they've been trying to figure it out and everything else, and they're like, it's spooky magic down here. No, it's not, actually. Study the big stuff, and then work your way down. So when we look out into space and we get the actual frequency of the hydrogen atom, because what they give you on the atomic scale is actually not the frequency of the atom, it's the level difference, RPMs. All right, so when you take a brown dwarf, okay, and you speed it up, you give it faster RPM, it gains mass. Well, it gains a magnetic field. It gets stronger. But its expansion, because the faster it spins, the more it wants to expand. Its expansion becomes extreme. We have brown dwarfs that spin every 85 minutes and stuff like that, every hour, does a full rotation. They're about the size of Saturn. So Saturn doing a rotation every hour becomes a brown dwarf. All right? It's about density, how dense is Saturn, and angular momentum. Okay? So Saturn is mass. It's not all that dense, but it's mass, right? So a moving mass generates a magnetic field. So when it moves forward, it generates a magnetic field. But it's moving forward through the magnetic field generated by the sun, which is rotating, which means the magnetic field is rotating. So as long as it stays at the right speed, it won't really be moving forward. Okay? It's going to actually get dragged along by the rotation of the sun. Now, from there, as Saturn starts to spin faster and faster and faster, what's going to happen is you're going to get a stronger and stronger. It's already got an extreme angular momentum, all right? And it's already got an extreme magnetic field. But if you speed it up, if you make it go faster, it gets a stronger and stronger magnetic field, crushing its mass into a tighter and tighter density. All right? And this generates heat, by the way. So what ends up happening is the faster a thing moves angularly, spinning, the stronger its magnetic field. And when you look at atomic particles, their angular momentum, their density and angular momentum is absolutely extreme. All right. So when they rotate like that, and they're that tiny, they have an extreme magnetic reaction. And a dipole is a particle that is rotating and moving through space. So particles are basically all dipoles. But the faster they're moving and the faster they're spinning creates a stronger and stronger magnetic field. So when we look at particles interacting with each other, we start seeing positive and negative particles bang, angular momentum. I'm seeing stars. When I look at these things that we're looking at for the particles banging against each other at the atomic scales, the actual test screens, I'm seeing stars interacting. And what you're talking about is density and angular momentum. It's not about positive and negative. It's also about spin direction. So if I got a star spinning this way and meets one going this way, it's going to cause a certain reaction that you ain't going to have when they're both spinning the same way. We see that happening in space too. We can calculate this. We have calculated this. We studied all of this at extreme, everything, up and down, left and right, all the way through. We get to the atomic scale where we can't see it, and suddenly it's magic. It's not magic. It's exactly the same thing, just scale to size.